Okay, Assalamualaikum. Hello. Uh, can you hear me? Someone can respond to me, whether you can hear me or not.
Hi, doctor. Can hear you.
Yeah, okay. So let me, where is it? So we have finished balance delta-delta connection. The next part is the balance delta-Y connection. Okay. So before we start, I would like you to check in your attendance here. Okay, make sure if you're section 15, you go to the left one. If you're section 16, you go to the right. Okay. Oh, it's not. Huh? Already take the attendance. So we continue with the. Okay. We move on to the next part, which is delta Y connection. So here, delta Y connection. Okay. So we, of course, the first thing you need to do is to draw. Okay. So let me move this. So delta Y connection. This one. Okay. Delta. Okay. Delta Y connection means that the delta is the source. Okay. And the Y is the load. Or you can write something like this, delta Y. Okay. Or Y also can be called star. Okay. So of course we have to first let me delete this first. So draw it. Okay. Same here. Of course you have to do something like this, something like this. Okay. Make a triangle. Okay, for the Y connection or the star connection, you have to make Y. Okay, the letter Y. So something, not Y. The inverted Y. Okay, thing like this. Okay, make sure you know how to draw this. Okay, this one, and of course this is connected to this one, and this one connected to this one, and this one connected to this one. So then label the this one A, this one is also A. The top one always A, the inside one always B, the outside one always C. Okay, that is how you draw this one. And then of course the current, of course, this one is IA, this one is IB because at B, and this one is IC. Okay, now you have to label the phase phase or line voltage. Okay, not phase or line voltage. This one is line voltage. Okay, so this one is VAB because we are from A to B. Okay, positive is A. This one is positive. This one is negative. Or if you want to use the arrow, use something like this. Okay, so this one VAB, this one VAC, VBC, and then goes up to the bottom VCA. Okay, make sure you know how to label this. Okay, and now for the current, you also have to label the phase current. So this is the phase current. So we start with here. So for delta, you can see here, phase and line current are same. So no need to label anymore because it's the same. But for delta is different. So remember, If IAB means that IAB, okay, from B to A. Okay, it is flipped from the from the load. Okay, remember that. This one is ICA. This one is IAB. Okay, sorry, IBC. Okay. Now you already label the star delta connection. Now how to calculate? So to calculate here, okay, let me. So at load, sorry, at source. Okay. So VAB V line is equals to V phase, but I line is not equals to I phase. So to calculate this, okay, you have to calculate from the load. You have to find the I phase equals to I line equals to V phase divided by Z. So you cannot start from the source. The source usually we just obtain the voltage. Now how about this? So if you obtain something like this, I suggest you do a, let me label this first, Z, and Z. So you can do a Kirchhoff voltage law. Okay, you do a loop here. Okay, so if you do a loop, something like this, so negative VAB plus ZIA, and then this one, because the current goes here, it should be negative at this part. So minus ZIB equals to 0. Okay, so okay, let me check the textbook. Okay, you can see here. If you want to use Kirchhoff voltage law, okay, you can do something like this. Okay, and you get something like this. Okay, IA minus IB is equals to VP divided by Y. So basically, if you want to calculate this, okay, you want to calculate the unbalanced load, you have to do something like this. Okay, you have to calculate like this, and then you have to do the second loop here. Okay, for the second loop, V negative VBC. Okay, VBC, and then for this case plus ZIB, and then for this case is minus ZIC, okay, negative IC, okay, equals to 0. So if you look here, this is how you calculate the unbalanced load, but that one will be discussed later. So for now, I suggest you just use the formula. Okay, so IA minus IB is just equals to something like this. So IA is basically V phase divided by this. Let me show. So for delta is V, remember the formula for balance load formula. Okay, remember back V line is equals to V phase multiplied by square root 3 angle 30 degree. Okay, you have to check back the previous video how to derive this. Okay, So after this, you just apply the formula because you already know the, okay, this one is, okay, this one is V phase is equals to V line, okay, and this one is V line, and if you transfer it here, V line not equals to V phase. So you already have the V line here. So V phase, you don't know it. So right now you don't know the V phase here. So just use the formula. So V line is divided by square root 3, yep, multiplied by 1R over square root 3 angle negative 30 degree. So make sure you know how to do this. Okay, if you divide an angle, it will become negative. Okay, if you divide it, okay, it will become negative. Or I just show you. Maybe some of you already forget. So this one is 30, okay, 1 over 30 degree. And VP is equals to VL multiplied by 1 divided by 1 divided by square root 3 angle negative 30 degree because you move it to the numerator. Okay, you just use this formula for balance load. Okay, right now, okay, so now we apply it because we want to find the phase voltage at the load. Let me move this. Okay, you just focus this one. So just use the formula VA, okay, VAN, okay, because this is neutral, okay, A from A to N, okay, the voltage from A to N, VAN, okay, VAN, we are used a different color. VAN is equals to, just use the formula, okay, V line is VAB, remember, if you see it here A, make sure this one is also A. Okay, divide by Z, okay, the load. VBN is equals to VBC divided by Z. VCN is equals to VCA. Okay, remember again, this one is C, this one also C. Okay, divided by Z. So you already obtained the phase voltage at load. Okay, so you already, oh sorry, this one is not V. Oh sorry, I used the wrong formula. Okay, let me, okay, so V phase, VAN, VAB, VBC, VCA multiplied by 1 over 3 and square root 3 angle 30 negative 30. Same as here, 1 over square root 3 angle negative 30 degree. Okay, multiply by 1 over square root 3 angle negative 30 degree. Okay, you use the formula above. And after that, then you find the, after you find the phase voltage, then you can find the phase current at load. Okay, after you find the phase voltage, you find the phase current at load. Okay, IA is equals to VAN divided by Z. IB, okay, you can see here, this is, okay, this is IA. Okay, you just find, you use the, you just use the Ohm law. VBN, okay, remember always find the phase current using the phase voltage divided by Z, and IC is equals to VCN divided by Z. Okay, so you already find the phase current here. Okay, you obtain the phase current. Okay, now the last part. Okay, you already obtained this one. You already obtained this one, and this one. Okay, now the last part is the phase current. Okay, phase current at the source. Okay, so let me. Okay, sorry. Let me show, because this is combined. When you combine it, it can be very confusing. So before I end it, okay. So basically, first you have to find the V phase at source, okay, and then you find the V line at source, okay, and then you find the V line at the line, okay. After you get the V line at the line, and then at the delta, you have to find the V line at the load, okay, at the load, okay. Okay, this one, sorry, the line and the load is the same, okay. So V line at the load, okay, and then you have to find V line, V phase at the load, and then you can find the I phase at the load. Then lastly, you have to find I phase, okay, at the line, at the source. Okay, this is the last part. Okay, so for this, because this is a balanced load, it is much more easy. But if it's not a balanced load, okay, this one will be, okay, I will show you later. So basically, if you want to find the unbalanced load, you have to apply Kirchhoff current law. Okay, at here, at A, B, and C, Kirchhoff current law. But because this is a balanced load, remember back the formula for delta, okay. So I line equals to IP, I phase, okay, multiply by 1 over square root 3 angle negative 30 degree. Okay. So this is the general formula for balanced load only. Okay, I repeat back, this one is for balanced load only. So you can see here you already find the line current. Now you have to find the phase current. Okay, so the phase current, of course, you have to adjust the formula. I phase current is equals to I line multiplied by 1. Okay, sorry, this one is square root 3 angle negative 30. Okay, and if you change this, swap this, okay, so basically it will become square root 1 over square root of 3 angle 30 degree. So you have to apply this formula. So IAB is equals to I A divided by square root 3 multiplied by 1 over square root 3 angle 30 degree. Okay, remember this one is negative. After you change it, it will become positive. Okay, so of course, and also this one, you can see here, this is A. Okay, make sure it is A and A. Okay, so IBC is equals to IB. Okay, remember B and B. Okay, multiply by 1 over square root 3 angle 30 degree. And lastly, YCA is equals to IC multiplied by 1 over square root 3 angle 30 degree. So this one is only for balanced load. Okay, now you already finished. Okay, so basically your task is just to calculate the line and phase current, line and phase voltage and current at source and load. Okay, so you have to find voltage and current, okay, at phase and line, okay, for the, okay, this one, okay, you have to calculate it. Okay, voltage and line, okay, you have to calculate 1, 2, 3, 4. Okay, the same thing again. Okay. A voltage, current at phase and line at, okay, you have to find 4 of these at source and load. Basically all of the 3 phase, okay, star star, delta delta, star delta delta, star connection, all of you of it, you have to find these 8 parameter. Okay. Okay, that's it for delta Y connection. Okay. You have any question? Okay, we take a break around 10 minutes. We will continue on 9 p.m. Okay?
Okay, doctor. Excuse me, doctor.
Yes?
Can I ask if you can provide some practice questions on this topic?
What?
If you can provide some practice questions for this topic.
Oh, for this one, I plan to do after this.
Oh, okay, perfect.
Okay?
I will wait for that. Okay,
Or
thank
you can use this one. Okay, there also a practice here you can use.
In the textbook, yeah?
Yeah, in the textbook.
Okay.
Okay, maybe we will discuss it later here. Okay.
Okay, thank you.
Okay, welcome.